Okay, for this video, we're going to be looking at symmetry on the coordinate plane. So symmetry in the coordinate plane. Okay, let's look at a coordinate plane here. And the first thing I want to do is I want to locate and I want to label a couple of ordered pairs. So the first thing I want to do is I want to locate and label 3, 4. So I'm going to do that now. I'm going to go over to the right 3 on my x-axis. I'm going to go up 4, 1, 2, 3, 4. And I'm going to put a dot right there. Okay, so there's 3, 4. Now I want to do the same thing with negative 3, 4. So because my x-axis is negative 3, I'm going to go to the left on my x-axis 3 spots, negative 1, negative 2, negative 3, and then I'm going to go up a positive 4. 1, 2, 3, 4, right there. Now, looking at these 2 points, what do I notice that they have in common? What do I notice that are different about them? Well, if I'm noticing about what they have in common, they're both 4 places up on the y-axis. So if I'm looking specifically at my y-axis here, which is right here, I can see that they're both 4 places up. So they both have the same difference there. If I'm looking at my x-axis, though, I'm noticing that there's a difference here. One of them is 3 spots to the left. One of them is 3 spots to the right. So what I want to do is, if I look specifically at what's causing that difference, well, if I'm looking, I have to pay attention to my x values, because they're what's causing the difference. 3 and negative 3. Well, if I'm thinking specifically about these numbers 3 and negative 3, what do I know about them? Well, I know that 3 and negative 3 are opposites. So if I know that they're opposites, and I think back to what my definition of an opposite number is a number or numbers that are the same distance away from 0. So if I think about where 0 is on my x-axis, because these are the x values, I know that 0 is right here. Whoops. I know that 0 is right there. It's actually right where my y-axis is. So if I count, I can see that 3 is 1, 2, 3 spots away. Negative 3 is 1, 2, 3 spots away. They're both the same distance away from 0. So 3 and negative 3 are opposites. They're the same distance away from 0. Another way to think about this is using absolute value. Okay, if I think about the absolute value of 3 and I think about the absolute value of negative 3, both of these numbers are telling me about how far away they are from 0. So 3, the absolute value of 3 is equal to 3 because it's 3 spots away from 0. The absolute value of negative 3 is 3. It's 3 spots away from 0. The only difference here is because 1 is negative, it's on the opposite side of 0. So again, what I'm able to tell here is these 2 ordered pairs have a lot in common. Okay, they're both 4 places up on our y-axis. They're both, for our x value, 3 places away from 0. But because one's negative, it's on the opposite side of 0 on our y-axis because of the x value. So what that means to us is that we actually have something called a reflection here. And if we think of a reflection, a lot of times we think about what it looks like in a mirror. When we think of the word reflection, we think mirror because a mirror gives us a reflection of light. So what we see in a mirror is opposite of what we see in real life. So if I was to think of setting up like a mirror right here on my y-axis, I can see that in my mirror, if I am 3 spots away, 1, 2, 3 from my point here, because it's a mirror image, I'd be 3 spots away here. 1, 2, 3. Okay? There happens to be a reflection, let's write that word down, on the y-axis or across the y-axis. And we can use that word reflection, or we can use what we know about symmetry to help us go from one point to the other. All right, so let's write this down. A line of reflection or a line of symmetry. We use those interchangeably. So a line of reflection or a line of symmetry divides a figure into two mirror image halves. So if we have a line of reflection or a line of symmetry, we're dividing a figure into two mirror image halves. So one half should be just what we have, or a mirror image of the opposite half. It's like looking into a mirror. You have the same image looking into the mirror that you have on the other side of the mirror. It's the same distance away. Our coordinate plane can work in the same manner. Okay, so looking at another example here. Let's say we begin at 7, 2. So we have our ordered pair where we begin at 7, 2. And what I want to do is I want to move down 3 units and then reflect over the y-axis and then figure out from there, where are we? So let's take this step by step. Let's start at 7, 2. So if I'm at 7, 2, I know that I am going to go 7 on my x-axis, 1, 2, 3, 4, 5, 6, 7, and then I'm going to go 2 on my y-axis, 1, 2, and that gives me a point right there. Okay, now from there, I want to move 3 units down. I want to move 3 units down. So I'm just going to sort of sketch this out. If I'm going 3 units down, I'm moving 3 down from that spot. 1, 2, 3, which gives me a point right there. Okay, I moved 3 units down. Now I want to reflect that over the y-axis. So if I'm thinking to myself, okay, I need to reflect it over the y-axis. So first I need to find my y-axis. That's my vertical axis right here. And I need to reflect it over that. So I need to see how far away I am from that y-axis. So if I count how far away I am from that y-axis here, I can count that I am 1, 2, 3, 4, 5, 6, I'm 7 away. So that means on the other side, I need to be 7 away. 1, 2, 3, 4, 5, 6, 7. And there's where my point should be. Right there. So now, where are we? Well, I'm at -7, comma, and I'm at -1 on my y-axis. So I'm at -7, -1. Okay, for my next example, I'm going to essentially do the opposite. Okay, so this tells me to begin at 9, -3 and end at -4, -3, and I'm to use one reflection. So what I need to do is I need to come up with the sequence, or I need to decide how I'm actually going to do that. So let's plot my points first. I'm starting at 9, -3, so I need to go, whoops, my graph doesn't go to 9, so I'm going to change this very quickly. Instead of 9, -3, I thought my graph went bigger. Let's start at 6, -3. Alright, so starting at 6, -3, there's my point. Okay, so here's my starting point. My ending point is at -4, -3, which is right here. So I need to use exactly one reflection. Well, looking at my graph here, I can probably tell that my reflections need to be over my y-axis. Okay, that way I can get over to the left side of my graph. So now I need to decide how I can get over to the left side of the graph. Okay, so if I'm beginning at 6, -3, and I need to end at -4, -3, the first thing I'm going to probably need to do is I'm going to need to get my opposite of -4, which would be a +4. So if I need to get to a +4, I'm going to need to move 2 spots to the left. Move 2 units to the left. Then once I've used 2 units to the left, I'm now at 4, comma, -3. So I'm going to reflect over the y-axis. And once I've reflected over the y-axis, I would see that I am now 1, 2, 3, 4 spots away. So a reflection would have to be the same number. 1, 2, 3, 4. And there I am, exactly where I wanted to end.